Today we're going to talk about pH, specifically how to use a pH meter for your cheese making. Whether you're a home cheesemaker, an avid hobbyist, or a commercial cheesemaker, it's all the same importance. pH will answer many of the questions you're going to have about your cheese making as you go along. If you're trying to troubleshoot and you call me, the first thing I'm going to ask you is probably what was the pH, or what was the start pH, or something to do with that. pH is a measurement of the free acid in the cheese and the milk. It's the control of that acid production during the whole process of cheese making that will make or break your cheese. Today, we're going to check some milk pHs, going to make some curd and check it along the way. Then we're also going to check the pH of some cheese, yogurt, and several types of cheese so that you can see how the results are and how you get an idea of what's normal and how to control it, and I'll talk about that. This pH meter I had for our commercial cheese making. I love it. Got it from Nelson Jameson. Fairly reasonably priced for what you get. And with a pH meter, you do get what you pay for. The more you pay, the faster it's going to be, and the more accurate, simply because it tells you, or they will help you know when it's actually done reading the pH. So this meter I have soaking in some 7 solution. You're going to have 2 types of buffer solution, 7 and a 4 pH. 7 is where I store my pH electrode all the time. So it needs calibrating usually several times throughout the cheese making day. Each pH meter is going to calibrate differently. So you're going to want to read the instructions that came with it. Nelson Jameson is a particularly good company about helping you troubleshoot problems, because sometimes things go wonky with the electrode. These are very sensitive pieces of equipment. There's the electrode and then the meter itself. So they have to talk to each other and everything has to be just right. But that's why when they work well, they work well. So I've got some water here to rinse the electrode in, and a static-free microfiber cloth that I use to blot it. Kim wipes also work well. So let's get right to it. So after calibrating your meter, you want to take a reading and dip it in that water, blot it off. We're going to check this cold milk. Milk varies greatly about what its pH is, what it reads for you, depending on temperature. So does cheese. Typically, the colder the milk is, the higher the pH. 7 is neutral. Milk normally is just below 7, so it's slightly acidic. If the milk is alkaline above 7, it's likely that there's a problem with the milk. Specifically, white blood cells that are in the milk to prevent an infection or fight an infection in the udder. So this milk is reading 6.65 at refrigeration temperatures. Now I'm going to dip it in a warmed up milk sample. And I don't have to rinse the electrode to go back and forth between milk. So this milk has been warmed up to the ripening temperature of about 85-88 degrees. Normally, no matter whether it's cow, goat, sheep, water buffalo, you're going to see about a 0.1 to 0.15, 2 drop in the pH. So it's going to look like it's more acidic the warmer the milk gets. Here we have 6.55. So just about 1, a little over 1, 0.1 in drop. Now, let's check our milk that I cultured an hour ago. So I brought it up to the ripening temperature, add the starter culture. Now we should see a very slight drop from the temperature that it was warm. You're not going to see a lot of drop, but just a little bit, because that bacteria is just starting to work. Controlling the acid production in the vat, in the pot, is the secret to starting your cheese on a good journey to have it turn out well. Many of the flaws that come in texture for cheese making, like if a cheese is too crumbly, which is a very common flaw in aged goat milk cheeses, it's because too much acid production occurred in the vat. Too much of that buffering capacity, minerals, were pulled out of that curd. So now we're reading 6.52. So only like a 0.03 difference from warm to cultured warm. You don't want to see a big drop at this point. Okay, so now I'm going to rinse the electrode, blot it off. And if you're rinsing in glass, be very careful. These little electrodes are very delicate. And this one, particularly being a spear tip, you can shatter it in your glass. By the same token, don't take it from a cold solution to a super hot because you'll break it. So we're going to add our rennet now and then let this coagulate. This is raw goat's milk that I milked from our goats this morning. Nigerian dwarf goats and a couple crosses, so it's a very dense milk. And this is winter when I'm doing this video, so the milk is even higher in components. One of these goats that I milking right now, her butterfat was 11% the other day. So it's thick stuff. And then we'll let this coagulate. And while it does that, we'll check some cheeses. So I'm going to, before I check these cheeses, verify that stored in the 7 solution, my electrode is still reading correctly on the meter. And it is. If you're making cheese and you're checking the pH toward the end of the process when the pH is lower, you're going to be fine storing it in the 4 solution. Wherever the closest number is to where you're working, that's what you can store it in. I've never used storage solutions. You just don't need it. You can use these. You can use them if you want, though. Okay, so first let's check some yogurts. Yogurt is a quite acidic product. A little more acidic than fresh cheeses such as chèvre and fromage blanc. This is a commercial yogurt that I particularly love, cow's milk, whole. And then this is some goat milk yogurt from our goat's milk. And you can see that it's an extremely thick texture because of the way I process the milk. I have a little book coming out next year on yogurt making, so I'll tell you how I do that. Then, so rinse the electrode, get that buffer solution off of there, and we're going to put it right into the curd of the yogurt. There is some whey separation in both of these, so there's going to be a little bit of a different pH in the whey than there is in the curd. And we'll see that in our little vat of cheese later too. So this is reading 4.02 to 4.03. And I'm going to swish it around in this little bit of whey. Let's see if we can get a different reading there. 4.05 or 4.06. And remember, the farther down you go or up past 7, so down below 7 or up past 7 on the pH scale, the smaller differences still mean extremely larger amounts of acid or alkaline if you're going high. So this is why being in control of this acid production is really critical. So pour 4.05 on this yogurt. I'm going to put it down in this curd. And I'm getting 4.19, 4.2. So this is a much milder yogurt. Now, when you get your electrode all gunked up like this, you're going to want to wash it. I'm to take mine over to the sink and run it under warm water and with a little dish detergent. Dawn, any of those kinds that are alkaline hand dishwashing detergents will work great. I've washed it. Now, before I check any other products, I'm going to want to soak it in that 7 again or in 4 and verify that the meter is reading correctly. And if not, I'm going to recalibrate. So the cheeses we're going to check today is a bloomy rind camembert that's very young and not too very ripe yet. Not ripe enough yet. And then a truffle flavored camembert type that's overripe. And 2 hard cheeses, a naturally rinded one and a clear coated one that is only aged about a couple months. So this is off, the meter's off just a little bit, so I'm going to calibrate. Calibrating in the 7 first. Rinse, blot, and into the 4. And if it reads correctly at the 4, I won't calibrate it at that number. You need to calibrate it if it doesn't read correctly. And you can give yourself, typically cheesemakers will give themselves a 0.03 variance. So like if this reads 4.03, it's within comfort zone. And it's 4.01, so it's totally great. Rinse it off. Let's try the hard cheese first. So hard cheeses, this is a spear tip electrode. If you don't have a spear tip, you can take a little bit of cheese curd in your hand, warm it into a wad, and insert your meter into that. This one though, I can push right down in there, and I'm going to push gently and slowly because I don't want to break the tip of my expensive electrode. The electrodes need to be replaced every few years. The better you are at caring for them, the less frequently you'll have to replace it. So this cheese at, it's a little warmer than refrigeration temperature, but not by much, is 5.11. That's probably about where it was when it was finished and salted months ago, or a couple months ago. They hold their pH. They don't change. This cheese, though, is also stable in the center at 5.35 or so. But because it's a naturally rinded cheese, the surface has been exposed to the environment, and surface microbes, specifically yeasts and molds, will have de-acidified the surface. Now I can just put that little tip right on there, and it's telling me it's zooming up towards over 6, which I'm not surprised at. So the surface is de-acidified. That's one reason that surface ripened cheeses and naturally rinded cheeses are at risk on this surface of becoming post-contaminated. So I've washed the electrode, recalibrating. Anytime you do a lot of testing of products that are heavy and solids like this, it's going to create a little fatty coating. You've got to wash off, and then you've got to recalibrate. Surface ripened cheeses go through the most profound ripening process. They are the ones that change the most in pH. When these cheeses start out, the curd inside is typically right around 5, maybe a little more, maybe a little less. As they ripen, the surface microbes, just like they did in these hard cheese, will de-acidify the surface. But then what they do, the white molds in particular, and yeasts, draw more lactate, which is the acid, out of the curd and consume it. And as they do that, they de-acidify the interior as well. As the interior de-acidifies, it's able to soften. If the cheese doesn't get the right ripening process or wasn't set up properly in the beginning, that will never happen. This cheese now, you can see it's firm still, so we're probably not going to have that much of a variation in the pH. This cheese, however, is very soft in the center, so we're going to see a very much similar, but it's going to be very high pH. So 4.02 in our 4 solution, a little rinse and a blot. And let's check the paste on this young Camembert style cheese. As with the milk, a temperature difference is going to make a pH difference. So just know that when you're checking your curd. So this is reading 5.05. I'm not surprised. It is still firm. The surface is going up towards 5.7 now, 5.8. So it's going to be over 6, which is great. It's a great start to this ripening profile for this cheese. And we're not surprised because we see a nice even growth, a nice thin rind of white molds. So I'm going to try going right into this guy, even though it's pasty, covered with paste. Move it around a little bit to get the surface contacting this cheese. 6.6. So it looks like about 6.7, which I would have thought it would be a little bit higher. Let's see what happens if I wash the electrode. Okay, so let's try this again here. Put it straight in that clean paste there. And there you go. So that washing made all the difference. It's 7.67 now. So there you go. The fatty coating on this one just couldn't read correctly through it. So high pH there, surface 7.7, moving up closer to 8. Is exactly what we'd expect. And again, an overripe cheese. These cheeses with their high pHs are considered the most risky, if you will, especially for pregnant women who are at more risk for, because they're under stress of not being able to process the same number of dangerous microbes that the rest of us can process daily. So handling them is something important to know because the pH is key. Time for another wash. So our milk has coagulated into a nice firm curd that has a clean break. So now I'm going to cut the curd. Well, actually, we'll check the pH first. As soon as you cut the curd, the whey starts being expelled, and then you're checking really whey pH more than curd until you're able to firm the curd up again and check it separately. So our meter is drifted a little bit just sitting there. So I'm calibrating again. And I'm going to check it in the 4. Your solutions, your pH buffer solutions, I change mine when I was making commercially once a week. Depending on how frequently you use them, how clean you keep them, you can get away with even longer. These are nice little snap top vials that can be closed in between, so you don't get contaminants in there. And this needs recalibrating at the 4 this time. There shouldn't be really any difference in the pH right now, unless you're starting to read the whey. So whatever it was when you added the rennet, it's going to be very close to that. So I've just inserted the tip in there, and it's 5.51. And I think we were 5.52 when we added the rennet. So just right. Not a lot of change. You don't want a lot of change in the vat for most cheeses. We're going to cut the curd. And I have no idea what I'm making today. I'm just making some curd, and at this point we could turn this into anything, just about. So you cut the curd, you're going to make a lot of surface area, and that whey is going to start expelling. So milk has a high buffering capacity, meaning, like our buffer solutions, it has the ability to absorb acid as it's produced and prevent a visible change or readable change in the pH level. pH, as I said earlier, is a measurement of free hydrogen, free acid, hydrogen ions. Depending on where those hydrogen ions are, your pH reading is going to be different. So, for example, with the cold milk, the hydrogen ions are hiding inside the protein micelles, the little structures that have all the calcium phosphate in them, or most of it. That's absorbed it. As it warms up, those hydrogen ions kind of leak out, and it looks like the acid drops. Like the acid increases, the pH drops. As this curd is cut, the acid production, the whey is leaking out, acid production is occurring, those buffers are absorbing as much acid as they can. So you're going to see stable pH or very slow drop for some time. You're racing that drop to try to get the curd to the texture you want so that it can withstand pressing and reforming into a wheel before a lot of acid production occurs. As that acid is produced, like I said, it's being absorbed by the calcium phosphate. As more and more acid gets produced, it starts pulling that minerals out of the curd. You use acid to clean your coffee pot, say, your tea kettle. Acid dissolves minerals. It's going to, if it reaches too high of a level in the pot, in the vat, pull those minerals out of the curd. Without a lot of mineral content in your curd, you don't have good structure of your final cheese. You don't have a good network of rennet either. So this is where goat milk can be particularly difficult because you're starting with less buffering capacity, generally. Nigerian dwarf goat milk, Nubian, and La Mancha to a great degree are a little easier to work with when you're trying to make a hard-aged cheese. If you're trying to make a fresh soft cheese, it's not an issue. You're not counting on a strong rennet structure in those types of cheeses. You're counting on high acid production to coagulate and make a fragile curd anyway. So we'll let this sit a little bit longer and go put it back in the warm sink. All right, so the curd is rested for about 5 minutes. That's giving it a time to expel a little bit of whey and firm up a bit. So just to give you an idea, this is what Nigerian dwarf curd looks like right after cutting. Looks a lot like sheep's milk curd. Very, very firm. This makes it easy to cut, but very difficult to stir at first because there's so little whey. The proportion of curd to whey is the ratio is much smaller. So you're going to move it around and let that whey start leaking out. So as I was saying about the curd absorbing the hydrogen ions, as the whey starts leaking out, you're going to start seeing a difference, a spread of pH. So the curd pH and the whey pH will stay the same for a while, but then you're going to start seeing higher acid production in the curd. This is fine. This is what you want. You need to produce that acid, but you're racing it. Now I've stirred the curd for a little bit, and there's quite a bit more whey in the pot now than curd, or not whey than curd, but there's more than there was before. So now we'll check the whey pH. At this point, any pH you check when the curd is this wet is, for all practical purposes, whey pH. The curd, even if I grabbed up a bunch of curd, there's still so much whey in that curd that it would be whey pH. So what we want to look for now is a slow drop. 6.49 is what we're reading now. So that's nice and slow. If it starts running on you, racing, you're going to be behind getting the texture. So then you'll have to develop some other strategies for slowing that pH down. One of those strategies might be washing the curd. By that, you remove some of the whey, which removes some of the lactose, which removes the food for the bacteria and helps slow the whey acid production. That's one way to do it. Another is to determine where the growth peak is for the bacteria that are in the milk. So for these mesophilic bacteria that are in this curd, these warm-loving bacteria, that's going to be right around 95. So if you get past 95, don't stay there for long. Go up a little higher, faster if the curd is small enough, and then you're going to get to where the bacteria slow down again. So there are various tactics that you can employ. Again, and much of this is covered in my book, Mastering Artisan Cheesemaking. So I would just continue to stir this curd, and we're not going to go through this whole process, but when the curd became dry enough, so towards the end of the process, then I would be able to take some curd, drain it, squeeze some of that whey out, and then check the curd that way. I basically, for most hard cheeses, you want to try to get this curd out of the whey, out of the vat, for most hard cheeses before it gets below, say, 6.4, 6.3. If you can do that and get it into pressing where the acid can continue to develop without draining away the minerals from the cheese, you're going to be in good shape. And for the final step of the process, you're going to leave that cheese in the form until it gets to your target pH. And for most hard cheeses, like I mentioned earlier, that's going to be around about 5.2, 5.4. Depends on the cheese. But as a rule of thumb, most of the cheeses you're going to make, unless you're getting into, like feta is going to be lower. It's going to be more like 4.7, 4.6. But it's not as much of a texture issue with feta. You want a crumbly cheese. But if you're trying to perfect the texture of your hard cheeses, acid production in the vat has to be under control. So that's some pH reading in a nutshell. I hope this has been helpful. Happy cheese making!